Hello, Algebra, and welcome to Unit 2. Hopefully this is going to look a little bit familiar. I think you were introduced to this idea in middle school, but if not, hopefully we'll get it explained now. So we're going to be looking at rate of change today. The learning targets, I want you to be able to find the rate of change between two data points and put your answer in the context of the problem. So what is rate of change? Well, rate of change allows you to see the relationship between two quantities that are changing. In a line, which is what we're going to be focusing on in this unit, the rate of change is constant. Now, that's only in a line. If you have a curve, the rate of change is not constant, and then what I'm about to show you does not apply. Now, how do you find the rate of change? The rate of change is the change in the independent variable. Change an independent variable over, and that line there is like a fraction bar, the change in the dependent variable. Now, those are big words. I'm going to try and make it a little easier for you. The independent variable is y. The dependent variable is x. So the change in y over the change in x. Another way you've heard of it, I'm sure, is rise over run. Rise being how much it goes up and down, so y. Run being how far it goes left and right, so x. So that's rate of change. Now we're going to look at finding the rate of change from different situations. The first one we're going to take a look at is from a graph. All right, so you can see a graph here. And I'm going to label 3 points on this graph. There's 3 nice points on this graph. You might even be able to argue that there's 4, but I'm just going to do these 3 right here. 1, 2, 3. So this is point 1, point 2, point 3. Okay, so they're nice points because both coordinates are in good positions. So you got 0, 0 for 1, 2, 1. Well, it's not 2, 1. It's 2 and 1/2 for the second one, and then 4 and 1 for the third one. All right, so that's what makes them nice points. Now we're going to look at the rate of change from point 1 to point 2. All right, so how much does y change in that? So it goes up 1 and over 2. Now, if you look at the scale, up 1 is actually up 1/2. So the y change is up 0.5. Okay, so it goes up 0.5. How much does x change? Well, it goes right 2. So what is the rate of change? Well, before we do anything with that, we got to look at signs. Up for y is a positive direction, so it's positive 0.5. And right is also a positive direction, so it's positive 2. And so my rate of change, we don't typically write it this way, so I'm going to write it off to the side here, 0.5 over 2, but we don't like to make that we don't like to have a decimal in there if we can avoid it. A decimal within a fraction, it's not good. I can multiply 0.5 by 2, so I'm going to multiply both top and bottom by 2. 0.5 times 2 gives me 1. 2 times 2 gives me 4. So my rate of change here is 1 over 4. Now, what does it mean in this problem? Well, it's right, like I said earlier, it's the change in y over the change in x. Well, the y is labeled in dollars, so it's the change in dollars or cost per, and what's the label on x? Ounces. So it's cost per ounce. So the way you figure out what it means is you look at the y label, and then you look at the x label, and it's the y label per the x label. Okay. Now, I made a point earlier that the rate of change is constant. We're going to take a look at from point 1 to point 3 and see if it remained 1 over 4. So how much does y change? Well, it's up 2 lines, but that's 1. So up 1 or positive 1. How much does x change? Well, it goes over 4 lines. So right 4. So +4. And if I write that as a fraction, look what I get. 1/4. How does it compare to the rate of change from point 1 to point 2? You might have guessed it. It's the same. Like we expected, it's a line. They have the same rate of change. Okay. Do the next one a little faster. Another graph, a tank of gas. A little different here because it's going downhill, right? As you drive, the amount of gas in your tank goes down. Before I do anything, I'm going to label some nice points. So the first one I'm going to label is right here. And the second one is going to be down here. I'm just going to do those two. How much does Y change? Well, it goes down 1, 2, 3, 4 lines. But if you look at it, look at the labeling, the scale, it goes from 15 down to 5. So it goes down 10 gallons, right? Down 10 gallons. We'll go ahead and put a label on that. What does X change? Well, it goes over 3 lines, but each line looks like it's 50. So it's right 150, and that's miles. So if what the rate of change is just that fraction, 10 over 150. But the problem is down means negative. So I got to remember to put that there. Always reduce if you can. So I can reduce, I can take 10 out of both of those. It's -1/15. So what does this mean in the situation? It means you lose or go down 1 gallon. The y-axis is gallons per 15 miles traveled. So basically you're getting 15 miles per gallon. So you're losing 1 gallon for every 15 miles you drive is what this graph is showing. All right, let's go ahead and go to the back. So I told you we'd look at finding the rate of change from a couple different situations. The second one we're going to use is from a table. We just did a graph. Now we're going to do a table. Now, is there a constant rate of change? This is a yes or no question. This is a lot harder to see than the previous one. So if you go back up here, I know it's staying in the way, but these are both lines, and you can see that they're lines. The graph shows you that it's a line. You should know that there's a constant rate of change. However, we get down here to a table, there's nothing graphed. So we have to check this before we can do anything. Don't want to assume that it's a line if it's not a line. Well, how do I do that? Well, I look at Y. So that's the second column. X is your first column. So I'm going to look at what's the change from the first one to the second one. So it's up 30, right? So +30. It goes, if I add 75 to 30, I get 105. Second one, from second to third, it goes up 45. I'm thinking, well, they're different, so it's not good. It's not just what Y changes. You have to look at it Y over X, right? So from 150 to 165 is 15. Now let's go over and look at X. Number of tickets. 5 to 7 is +2. 7 to 10 is +3. And from 10 to 11 is obviously +1. To look at this, we need to make a fraction. So I'm going to look at the change in X, or sorry, the change in Y, so 30 over the change in X, so 2. Reduce that, I get 15 over 1. Let's look at the second one. So I'm going to erase this. Let's look at the second interval. So from here to here, that was 45 over 3. What does that reduce to? 15 over 1. And then if you look at the last one, that one's pretty easy. +15 over +1. They all reduce down to the same thing. So is there a constant rate of change? Yes, there is. We've got a line. What is the rate of change? Well, we just did all the work to figure that out. It's 15 over 1 or just 15. You can just write 15 if you want. What does it mean in this problem? It means the cost, right? So $15 per, and then the x-axis is, or the x label is number of tickets, so per ticket. So whatever this is, it's $15 per ticket. Okay. Let's do another table. You can probably guess what's going to happen, but maybe not. Let's take a look. We got to check, is there a constant rate of change? From here to here goes up 20. One thing you could also do, and I didn't do this last time, if you want to go and do the interval from the first to the second and see what that rate of change is, and then move on to the second to the third, it's another way of doing it. From 0 to 5 is 5. So if I do 20 over 5, I get 4. Or 4 over 1. Let's look at the second one. From 20 to 30 is up 10. From 5 to 8 is up 3. So 10 over 3 cannot be reduced. Therefore, those are not equal. And I do not have a constant rate of change. What does that mean? Well, I can't answer number 2 and I can't answer number 3 because there is no constant rate of change. It's not a line. Okay. All right, almost done. Let's look at the third way of finding rate of change, or third situation where we find rate of change from a situation, or from a, I have to say a situation. The baby giraffe was 70 inches tall at birth and 103 inches tall after 3 years. What are the 2 data points we can get from this? Well, we're going to let X be age, and we're going to let Y be height. So you can see that we've got a change in X and a change in Y. So the age at birth is 0. How tall? 70. The age after 3 years was 103. So what's the change in Y? It's up 33. And then what's the change in X? It's up 3. So 33 over 3 is 11 over 1. There's my rate of change. Now we can go ahead and assume that it's a linear relationship. It means the rate of change is the same. I know giraffes probably don't grow the same exact amount each year, but for what we're doing right now, we're going to go ahead and say that we can say it's a constant rate of change. What does it mean in this problem? I kind of referenced it already. The giraffe grows 11 inches per year. All right. Very similar problem with the next example. After 3 days, the farmer had collected 38 total eggs. After 7 days, he had collected 194 eggs. So X is going to be the number of days, and Y is going to be the total eggs. So the change in Y is the total eggs, right? So 38 and 194. Well, I got a lot more there. 194 minus 38. I don't have a calculator right here on me. Let's do the old school math here. We got 156. So 156 eggs is the change in Y over the change in X. So from 3 to 7 is 4 days. And then divide to get that in reduced form, you get 39 over 1. What is the rate of change? 39 over 1. You don't have to, if it's over 1, you can just write 39, but it does help with labeling if you have it as a fraction. So what does it mean? It means 39 eggs per day. And that is rate of change. We're going to talk about slope and how it's related to rate of change in the next lesson.